Okay, so our unit that we are starting next is our unit on similar triangles. And this requires us to deal with ratios and proportions, which means sometimes we have to convert values, as we can see here. So sometimes we have to do some conversions. I know this is back from elementary and middle school for you guys, so a bit of review with this. And so just want to recap some of our conversions, make sure we remember gallon, man, or whatever it is you guys did, as well as some of our metric conversions, things like that. So if you would go ahead and check your answers to this with someone nearby you, see if you got the same values. Yes. Alright, so we'll go through and see which ones are right and fix any that might be wrong. Do we agree that 1 centimeter is 10 millimeters? No.
Yes. Yes.
Now, we agree that 1 centimeter is 10 millimeters.
Wait, what?
So 10 millimeters makes up a centimeter. Good. Now, building upon that, 1 meter is 100 centimeters, which means it's then 1,000 millimeters. Okay. Now, in terms of our English standard units, about how long is a meter? Almost here. So just so we have about an idea of how long it is. All right. So then 1 kilometer. Put away the phone. I'm looking at I'm going to go over it. Put away the phone.
Are you going to draw them out for me?
Put away the phones. So 1 kilometer is 1,000 meters. Again, we could continue with how many centimeters, pounds, and how many millimeters. All right. Do we agree that 1 gallon is 4 quarts? Yes, we're good with that. All right, so there are 4 quarts in a gallon, ladies.
Yes, I'm talking, guys.
Do we agree that 1 quart is 16 cups?
No!
So those that changed it no longer agree with this?
No, that's Asia.
I'm pretty sure I remember hearing you guys say change.
It's 4. I would encourage you to say it. It's 8.
Alright, talk with your shoulder partner real quick. How many cups are in the
4.
It's 4.
You gotta get your now.
So who would write it? Don't you have waiting to be, alright? You're gonna
And the queen had 2 princesses. And then
Alright, quiet down. Bring it back up front. How many cups do we think are in a quart now? 4. Now please listen. I know various people have learned it different ways. In 1 gallon, there are 4 quarts. Within each quart, there are 2 pints. And in each pint, how many cups are in just 1 pint?
2. Therefore, there are 4.
2 crowns.
Yep, so then in 1 quart, there are going to be 4 cups.
They're cash.
Alright.
And so each
Alright, so whatever method you use, just quiet down. Whatever method you use is fine, but make sure you remember the method. Alright, 1 yard, 36 inches, are we good with that?
Yeah.
How many feet are in a yard?
3.
And how many inches are in a foot?
16. Wait, what?
12. Alright, now 1 mile is indeed 5,280 feet.
That's a lot of feet.
No, it's 1,760.
You know, I'm just cleaning it up a little bit.
Yeah, Asia.
I rolled back. It's just a body.
And that is 1,760 yards. Now you need to know this. If you do not know this, commit this to memory. Alright, so in front of you, you should have received the notes that look like this. Is there anyone that did not get the notes? We're good? So if you need to add any of those to your notes here, so for example, if you need to remind yourself that 1 mile is 5,280 feet, which is 1760 yards.
Wait, can you go back to the gallery?
Please do so, because you need to know these conversions. You will not be given any conversions. You need to be able to make the conversions.
I'm gonna get a tattoo.
I could ask you how many inches are in a mile as well, and you would be responsible for figuring it out. Probably a pretty big number. Alright,
Can you go back to the gallery?
yeah. So again, if you need any of these added to your notes, go ahead and write that down. Now some of the easy ones that everyone knows, like 12 inches in a foot, obviously that's not there, but if you need to write that down,
Wait, there's 2 cups of each.
and each kind. Alright, so again, our unit that we're working with is similar triangles. And similar triangles require us to deal with ratios and proportions. Now, we are not going to have triangles measured in gallons, but part of this is that we are able to do these conversions. So we're doing conversions with lots of different things, not just with our length. But you'll see what we focus on is deals with the length. So we're going to be more likely to deal with our metric units there with like meters, centimeters, and then of course like inches and yards. Alright, any questions with this? Alright, so a ratio. This is a key word here. And I know this first part of our notes is probably familiar for a lot of you. But we're just kind of recapping. So ratio is a comparison of 2 quantities. Now we have 3 different ways that we can write this comparison. We can use a colon, we can write it as a fraction, or we can actually use the word 2, 3 to 5. Alright, so that's just an example of a ratio. And they are typically written in the same unit. So you can see our first few problems here, it requires us to first convert it to the same unit and then simplify. Make sure you always write what unit you're working with. Especially if the units are different, you have to specify what each number's unit is. Okay? So again, a ratio is comparing 2 values, and we'll be doing ratios throughout this whole unit. So number 1 here says rewrite the fractions with the numerator and denominator have the same units and simplify. I recommend that you go to the smaller units. So here for number 1, the smaller unit would be hours. So convert everything to be in terms of hours. So now the question is, how do we do this? Again, I know you did this in middle school, but it might have been a little while. If I want to convert, so the top is in days, the bottom is in hours. Let's finish it all in hours. How do I convert 4 days to hours? What do I need to do? Okay. Careful, I don't want to cross multiply. Teresa?
I could simplify like make it like 2 days over 8 hours, and then 8 hours is 48. 2 days is 48 hours.
Good. So I'm going to kind of expand upon what Teresa just said. First of all, we can simplify. We want to simplify when we can. But second of all, Teresa, you did something in your head there that I want to make sure we all understand. She said 2 days is 48 hours. How did she do that? What did she do to get from 2 days to 48 hours?
1 day is 24.
Yeah, 1 day is 24 hours. So if I want to know how many hours these days are, do you agree we just multiply by 24? Okay, so I'm going to go ahead and write that out. 1 day is 24 hours. So I'm going to multiply by 24 hours on top. Now, I don't remember which science class it is that you do this in, but in one of your science classes, you'll be doing conversions, and sometimes you do something like this. So I want to know how many hours are in 1 day. So 24 hours in 1 day, that means I'm going to multiply these together. You don't have to write that out. You could just simply multiply by that 24. But if that helps you to kind of visualize what's happening there, by all means do so. Alright, now as Teresa said, we could simplify before we started, right? I can also simplify with my multiplication here. So let's go ahead and simplify that very beginning. What does 4 over 16 reduce down to?
1 over 4.
1 over 4? Do we agree with that? Yes. Okay. So now if I go ahead and multiply by 24, I can still simplify some more. What else can I simplify here? Yeah, 4 and 24. What would 24 reduce down to then? Good. And this would become just 1. Notice how much easier it is to multiply now. When I'm multiplying fractions, I multiply straight across. So 1 times 6 would be 6, and we converted it all to hours. And 1 times 1 would be 1. And again, we convert everything to hours. So we have 6 hours to 1 hour, which that simplifies down to just 6. But again, I want to go ahead and remember that it is a ratio. If you simplify that down to 6, that's okay, but we want to keep in mind this is a ratio. So I'm not sure what we're comparing here. Perhaps this is how long it takes a snail to run a mile compared to a caterpillar to go a mile. I'm not sure, they didn't tell us. But in the end, I can see however long it takes, or however far a snail goes in 6 hours is how far the caterpillar goes in 1. So keep in mind that it's comparing those two values. The what? I don't know what that method is, but as long as you fix the answer. Does that make sense for number 1 there?
Yes.
Alright, now let's take a look at number 4. Number 4, they threw in a decimal in here. Don't let that throw you off. We see we have millimeters and centimeters. Again, I recommend you go to the smaller unit. So let's convert everything to millimeters. How many millimeters are a centimeter? 10. So I want to multiply the bottom here by 10. Again, you can think of it this way. There are 10 millimeters and 1 centimeter. Okay, so again, I want to have kind of that opposite, or the units in opposite places there. So you can just think of it as multiplying by 10 in the bottom, or you can think of it that way, whichever you prefer. So if I go ahead and simplify here, again, we can reduce beforehand, but I don't want to deal with that decimal, so I'm going to multiply that together. So I have 80 millimeters and 0.6 times 10. There's 1 0, so that means I move the decimal place 1 place. So it would be 6 millimeters. Does that make sense what I did there? 1 0 equates to moving the decimal 1 place. Are we good with that? Okay, so what would this reduce down to?
40.
Good, 40 over 3. And again, that's millimeters and millimeters. Doesn't look like millimeters, does it? You need to know your conversions. No conversions will be given to you.
Oh no.
Oh, got it.
Alright, so again, we want it to be in that same unit. It just helps us to get a better understanding of what the comparison is. Because if I said, like, 5 meters compared to 255 miles, those are different units, so it's kind of hard for me to have an understanding. I know that the 5 meters is pretty small and the number of miles is pretty big, but just how drastically different is it? And that might be better to say, like, let's say 10 centimeters compared to 10 inches. Again, I know that they're similar, but how close is it? So in comparing, getting in the same units allows me to get a better understanding of exactly what we're working with. I want you guys to go and try number 2 and number 3. Think of your answers, go and compare with someone next to you.
to Michael back. Just like, when I started reading that too.
Yeah, go. Yeah, go.
I never think eat it, but the middle was I never thought of it like
Oh, wait.
I never.
Wait, what did you get for? Oh, did you get 90 over on code?
Yeah.
What did you get?
3 meters.
Alright, number 2. Did we multiply by 3 feet on top? Good with that?
Yeah.
Alright, so again, you could have reduced in the very beginning, right? For every yard, that's 3 feet, so that's why we multiply by 3, because 1 yard has 3 feet. So again, we can reduce in the very beginning, and this would give us 3 over 1. Do we agree with that? And so then when we multiply straight across, we get 9 feet, and again to the 1 foot. Good with that? Okay. Do we agree that there are 1,000 meters in 1 kilometer?
Yeah.
Okay. So now when I go ahead and multiply across, again I see 3 zeros, so that's going to move this 3 places. So that would be 600 meters over 200 meters. And this one even simplified down pretty nice as well. 3 meters over 1 meter. Are we good with that? Do we have questions on any of these 4? Okay. So again, that's just kind of recapping what you did in your younger years. Now moving on to proportions. So this is really important here. Go ahead and highlight it, put a star next to it, do something to make it stand out to you. A proportion is an equation that states 2 ratios are equal. So we have a ratio equal to another ratio. I'm going to write that in. Ratio equals another ratio. An example of this, for example, what we just did up above here, 600 meters over 200 meters, right? 600 over 200. Well, that's simplified down to just 3 over 1, right? Likewise, maybe I have 5/10. What does that also equal to? 1/2. Which is also equal to 50 100ths, right? Sorry. 50 100ths, or 500 over 100, 50 100ths. So again, a proportion is just 2 ratios that are equal. We use proportions with those ratios to help us solve for unknown values. That's kind of what we just did up there. That maybe I might have something like this. 2/3 equals x over 8. This is a proportion in which I have that unknown value. I know that this ratio on the right, x over 8, must simplify down to 2/3. So I set up those 2 ratios equal, makes that proportion, and then I can use algebra to help us solve for that unknown value. So we're going to first investigate our properties of proportions, because this can help us in solving our proportions as we deal with triangles. So first of all, in this example here, how would I solve for x? What would you guys do? Come on. Cross multiply. Now I want to make sure we are all very clear on what cross multiplying is. So cross multiplying is when I have one single fraction equal to one single fraction. Then 3 times x is equal to 2 times 8. Or in other words, 3x equals 16. Divide by 3, divide by 3. This does not reduce, so x is 16/3. Do we agree with that method for solving?
Yes.
So that's your cross multiply. Now, let me ask you, if I have to do 2/3 plus 1/5, can I cross multiply here? No. What if I have 2/3 minus 1/5? Can I cross multiply? No, that's the same thing. What about 2/3 times 1/5? Do I cross multiply? No, how do I multiply fractions? Straight across. Good. What if I had 2/3 equals 1/5, let's go, x over 5, plus 5.
Yes.
Can I cross multiply this here? Right, we need to have it one fraction equal to one fraction. I would need to subtract my 5 or get a common denominator, bring it to where it's one fraction equal to one fraction, then you can cross multiply. If I see that we cannot cross multiply in proper situations, then I will revoke that right from you. 2 years ago, I didn't let them cross multiply because I couldn't handle it. I trust that you guys can cross multiply. So don't start cross multiplying anytime you see fractions.
Samir, please don't.
You have to get a common denominator here.
Samir, please don't. It's the only.
So guys, listen up. So it was asked, how do we deal with this one here? I would have to first get a common denominator. I would probably subtract 5 from both sides. And I need to write that 5 as a denominator 3. What would that be?
15/3.
15 over 3. Now I can combine those, so I would get negative 13 over 2. And then from here, now you can cross multiply. Does that make sense how we would solve that one in green there? Just above. Okay.
It's like a squeeze.
So I asked you to go ahead and solve for number 5. Please write down. What did we get for our answer for number 5?
2.
Raise your hand if you cross multiply. Did anyone only multiply to get there?
Yes, but.
Just multiply by one number to get to your answer? Okay, so we can cross multiply for this. Monty, please put it away. So I can cross multiply and get 20x equals 40, right?
Yeah.
And then I divide by 20,
C.
divide by 20, so I get x equals 2. You good with that?
Yes.
Now, sometimes we have to deal with pretty large numbers, and so cross multiplying might actually be a little bit more work than is necessary. So take a look back at it again. The only thing that's causing issues with x is that we're dividing by 8. So to get x by itself, I just need to get rid of that a in the denominator. Well, what's the inverse operation of dividing by 8? Yeah, just multiply by 8. So I could have just multiplied by 8 on both sides. And then I would have x equal 5 times a over 20. So again, you could do that mental math of 40 over 20. Or just like we were doing up above, simplify. 8 and 20 both reduced by 2. Or sorry, both reduced by 4 would be the larger value. 8 divided by 4 is 2. 20 divided by 4 is 5. And my 5 is reduced, and I'm left with just 2. Alright, so you can also do that to help save you time. Sometimes you're going to have to cross multiply. But this is an instance in where cross multiplication was not necessary. It still gets you to the same answer, just one step more. Does that make sense what we did there?
Yeah.
Okay. Also, this allows you to deal with smaller numbers, to work with smaller numbers in terms of that simplified. So let's take a look, for example, at number 6. Again, we can cross multiply, and we have 13n equals 5 times 52. Notice how we're starting to get into those bigger values. So again, I can still cross multiply. I can go multiply out 5 times 52. What is that? 260. But that takes some time and we might make a mistake with it. So instead of multiplying that out, you could again go ahead and reduce. You can, if you wanted to cross multiply, that's fine. But leave it written as 5 times 52. Divide by 13 on both sides. Does 5 and 13 reduce? No. But perhaps 52 and 13. What's 13 doubled? And what's 26 doubled? 52. So again, to save yourself some time, I can reduce 52 and 13. What's 52 divided by 13? 4. And 13 divided by 13? Which is 1. So now I can, a little bit quicker, get my answer of 20. Does that make sense what we did there? So this is what I call working smarter, not harder. Instead of multiplying out a big number, then dividing it by kind of a large number as well. We deal with just the factors and reduce our factors. Let's go money first, Idris.
And still has to just do the cross multiply.
Yeah, I cross multiplied here. I did. So 13 times n.
For saying the other one on that one and the other one on that one. Do you have to do that?
No. It's just another way to get to your answers quicker. Teresa, do you have something?
I think the 260 thing is easier than 13 goes to 26.
And that's fine. You're welcome to do that. For some problems, our values start to get bigger and bigger and bigger, and it's harder to do that with. So guys, you are perfectly fine in multiplying out 5 times 52. But what if I had 15 times 52, and then I had to divide that by 5? It's going to be a little bit easier to simplify that 15 and 5, and then go from there. Okay, so I'm just showing you ways that you can work with the arithmetic a little bit faster. Alright, so again for number 6, you could have, instead of cross multiplying, if you wanted to, just multiply by 52 on both sides. And again, then reduce 52 and 13 as 4 and 1, and then you get your answer 20. So, whichever of those 3 methods you'd like to use, that's perfectly fine. Alright, let's go ahead and do number 7. I want you to try that on your own, and then compare with the person next to you. You're going to need to cross multiply here.
Did you get 62? So just 7? You want to do 7?
Yes.
Did anybody get 62?
Alright, I'm going to write 2 answers up here. I want you to decide which one is correct. And then I want you to figure out what went wrong to get that other guy.
Probably all that, but it's okay. Whoa.
Alright, so talk with your shoulder partner. Which one is correct? And then for the one that's wrong, what happened? What was the mistake that was made?
One is actually 4, and then line 2. They probably guessed. Oh, she probably guessed. She's like, 11's a good number. I haven't picked it in a while. She probably picked 11 this time.
This is a common mistake I see with students, so I want to make sure we don't make this mistake again.
If I do a multiple choice test and I don't get C for like probably the questions like this is gotta be C. This is gotta be C. Yo, Mr. K, Mr. K made a test one time.
Alright, what did we get for answer? 62. Do we agree 62 is correct?
Yeah.
Right. Now, was anyone able to identify what went wrong with the 11?
You just multiplied the variable y and not the form the 7.
Very good, very good. So let's take a look at this. When we cross multiply, we should have 6 times the quantity, y minus 7, equals 5 times the quantity, y plus 4. Do we agree with this?
Wait, yes.
And then we have to distribute, and we end up getting 6y minus 42 equals 5y plus 20. And that's what yielded this answer of y equal to 62. A common mistake that I see, Samir, put it away, please. A common mistake that I see is that students will multiply just the 6 times the y, and they'll say 6y minus 7, and then multiply just the 5 times the y, 5y plus 4, and that is what yielded this answer. That is wrong. You must seal that in parentheses and distribute this through.
Also, the only
Are
distribution.
we good with that? I see this mistake a lot and I don't want to see it. So I want to make sure we all understand that we must seal in parentheses and distribute. Are we good? Okay. So now let's talk about our properties of proportions. There are certain properties that allow us to sometimes solve equations a little bit quicker. And then there's one that's kind of a unique property. It doesn't, you won't see it a whole lot, but it's an important one to know. So let's first write it out. We have three things that this proportion is equivalent to. So we're going to write it out and then we're going to see why this is true. Alright, so a over b equals x over y is equivalent to, let's start off with b over a equal to y over x.
What does that do?
So what happened there?
You flipped to them.
Yeah, the whole thing got flipped upside down, right?
Wow.
Why would you do that? Oh, why would you do that?
Does that make sense what happened there? I can take a proportion and take the whole thing and flip it upside down. Are we good with that?
Yeah, but why?
The reason why this might be helpful is if I had, so over here I had 2/3 equals x over 8. If I had 2/3 equals 8 over x, without cross multiplying, you would have to multiply by x on both sides, and then you would have to multiply by 3 on both sides, and then divide. So it's nicer when our variable is in the numerator. It does not have to be. Cross multiplying takes care of that issue for us. But it's nicer for us to have that unknown value in the numerator. So if it's an x number, you can flip the whole thing upside down. Again, cross multiply will take care of that for us.
Wait, so if the variables in the denominator can still cross multiply?
Yes. That's why I said cross multiply takes care of it.
I know, but like.
Alright.
Still.
So again, what does equivalent mean? It's the same thing, right? So this is the same thing as what I just wrote in class. It's just another way of writing. Just like 4/6 is the same thing as 2/3, just another way of writing it. Now our next one. I can say that a over b equal to x over y. I could rewrite this as a over x equal to b over y. A over x equal to b over y. What happened here?
You divide the numerator together equal to denominator.
I flip-flop that diagonal, right? We can do this either way. I could flip-flop that diagonal. I could flip-flop the other diagonal. If I really wanted to, I could flip-flop both. Again, this is just another property in which you might prefer to solve for the problem in that way. Yes, Mike?
We're getting into this.
It's possible you might see it in a proof, yeah. So your reasoning would just be property of proportion.
So we have to recognize that all of this, memorize all of these properties.
You should know the properties, yeah. Alright, now our last one's kind of weird. Again, you won't see it very often, but it is helpful for us. A over b equals x over y is equivalent to, or it's the same thing as saying, a plus b over b equals x plus y over y. A plus b over b equals x plus y over y.
Wouldn't that just say that a is equal to?
Let's talk about why this is true. When I have a fraction with two pieces in the numerator, from algebra 1, do you agree that we can rewrite this as a over b plus b over b?
Yeah.
You good with that? Or just break up that numerator? Equal to x over y plus y over y? Do you agree with that? Alright, what's b over b? It's just 1. What is y over y? 1. And then if I subtract 1 from both sides, what do we get? A over b equals x over y. So all this is saying is that I can add the same amount to either side of the equation and get that common denominator. Okay, so again, not as common, but you might seem to be able to recognize it as a property. And these are really just algebraic methods as to how we solve for these. These first two come from dealing with that cross multiplying. So when I have that a over b equals x over y. And I cross multiply. So I'm going to essentially cross multiplying says that I multiply by the denominators on both sides. Right? I'm multiplying by b and y on both sides. Sorry. Let me actually just rewrite that. So when we cross multiply, I have a times y equals b times x. Do we agree with this?
Yes.
All right, so that's just what my cross multiplying does. Now these properties, these first two properties comes back to this cross multiplying. So for example, for this first one here where I have b divided by a, take a look. If I take this multiplication here in blue, and I go ahead, I want to have b divided by a. So I'm going to divide by x on both sides, and I'm going to divide by a on both sides. Watch what happens. My x is reduced, so I have b over a. Over here, my a is reduced, so I have y over x. Isn't that just the same thing as b over a equals y over x?
Yes.
What property allows me to take this green and switch it around for that black?
Property of proportion.
Not reflexive.
Symmetric.
Symmetric. Symmetric property lets me take that entire equation and flip it around, right? So the reason why this first one is true is because of what we just did there in the blue and green. Okay? So this is the algebraic reason why that is true. Questions on that? Alright, so now let's take a look at why this next one would be true. Again, I'm going to go back to my original cross multiplying here, which was a times y equals b times x. So if I go to show why this one is true, notice it's a over x, so I can divide both sides by x, and I want to have y on the other side. Again, similar idea. My y is reduced, my x is reduced, and I have a over x equals b over y. That's what we have here. So again, that's just the algebraic reason. That's why we're allowed to do that. I'm not making up these properties. There's the algebra to show you that it is indeed true. Are we good with that? Questions with that? Alright, let's go and take a look at our backside. Now, I believe you have some information already filled in, so let me fill that in. Go ahead and read what's in that box there while I fill in this information.
Awesome. Yeah. Choosing for like hoodies, dude. It's not even a good. I know. Like, what is it? Come on. Fill it up. Just fill it up. I see that. Oh, dude, you're leaving it open. Huh? Go. Jemma does this? No, look. Mine's already used to it. So, like, when it goes like this, go like, bam. Oh, there you go. You're running the method. Oh, like, what are you gonna curl? Bro, if you like the cheap idea. No. Hey.
Alright, if you would real quick check to make sure it's my picture match what you have on your notes.
Yeah. I did.
Yes,
You
good.
Alright,
And do my letters up here match your letters?
Yes. I can't move that
Alright, so now moving more so into the geometry side of what we're doing today. We have two polygons are similar, and this is a key vocab word for you to know.
You're not.
Are similar if their corresponding angles are congruent. So the corresponding angles are congruent. But what's different than what we did before is that the corresponding sides are proportional. Okay, so the angles are still congruent, but corresponding sides are proportional.
Wait, I don't understand what this is.
Well, that's why I have to explain it to you.
Oh my god.
Please stop talking.
She doesn't like this.
So again, two polygons are similar if their corresponding angles are congruent. That's still the same as before. But now their corresponding sides are proportional. So let's take a look at what it means, again, to be proportional. A proportion is an equation that states two ratios are equal. So if I have sides are proportional, that means that the corresponding sides have the same ratio. Right? Same ratio. Because again, a proportion has two ratios are equal. So if my sides are proportional, they have the same ratio. And the symbol for similarity is just that squiggle. We don't have the equal sign underneath, just the squiggle. Okay, so before we dealt with congruent figures, now we're dealing with similar. So for example, in this first picture here, we are given that quadrilateral ABCD is similar to quadrilateral GEOF. From this statement, we can know the following. Those angles are congruent, so angle A is going to be congruent to which angle?
G.
Good, angle G. So again, we match up the letters, just like they are in the similarity statement. Angle B is congruent to what angle? Good, angle E. Angle C is congruent to angle O. And angle D is congruent to what angle? N. Alright, so that's the easy part. That's our corresponding angles are congruent. Now, what does that mean for the corresponding sides to be proportional? Again, the ratios are the same. And a ratio is just a comparison of two values. So AB, what side does AB correspond with? GE. So if I were to do the ratio of AB to GE, thus I can see here the measurement of AB over the measurement of GE, that's a ratio. I don't know what those values are, but that is some number, some ratio. That's going to be the same for every set of corresponding sides. So I should get the same ratio when I compare BC to what? EO. And again, I should get the same ratio when I compare CD to ON. And again, I should get the same ratio when I compare AD to GF. So each comparison of the corresponding sides gives us the same ratio, meaning they're proportional, the same ratio.
So, is this group with like, given something, and then you're like prove AB over EE is BC over EO, would you have to like go through and like prove how the two things are similar?
Yes, you need
So
to.
you have to find like all the angles, and then or like find angles figure, and then you can use that thing for like angles.
So
No,
we're
because you can't.
We're going to use something, so just like in congruent triangles, we had certain methods to prove the triangles were congruent, like side, angle, side, angle, side, angle. We're going to have certain ones that show triangles are similar. So you do have to first show that the triangles are similar, and then you can say something about those corresponding pieces.
But that's like
Yeah, yep. Is there photo?
Yeah. So like, when it asks for the proportion, you have to put all of that.
So good question. So this here statement of proportionality is that which we just wrote here. The statement of proportionality is stating all of our sides proportional, same ratio. Now, we're going to mainly be dealing with triangles, so you have 3, but here we had a quadrilateral, so we had 4 sets of sides. Okay. Alright, so again, statement of proportionality means we're stating those proportions, so the ratios are equal. So in order for me to show that a set of figures is similar, as of right now, we have to show all 4 angles are congruent and all 4 sides have the same ratio. That's what allows us to show that 2 figures are congruent, or sorry, similar. Just like last unit, to show 2 figures were congruent, when we first started out, we had to show all sets of angles were congruent and all sets of sides were congruent. Now, as I was telling Amani, we're going to have certain shortcuts to help us show that triangles are similar. We'll be learning one of those today and then more in class. Alright, Are we good on what this means to be similar? Two figures. Alright, so now our scale factor. Our scale factor is the ratio of the corresponding linear measurements of two similar figures. Let's translate that. First of all, we see it's a ratio. And then it says corresponding linear measurements. Linear measurement, that's just saying the distance or the length of it, of two similar figures. So all this is saying here is that this is the ratio of the sides. Or if you would, side lengths, we're talking about actual numbers. So the ratio of our sides. So for example, our triangle down here, we have that the angles are congruent. We can see that angle A is congruent to angle X. We can see that angle B and angle Y are congruent, angle C and angle Z are congruent. So they took care of the fact that our angles are congruent. But what we need to check to see is, do the corresponding sides have the same ratio? If so, then that's my scale factor. Alright, so let's take a look at this. Now here they gave me my similarity statement. Just like before we had a congruency statement, now it's a similarity statement. So I can say side AB and side XY are proportional. So side AB is corresponding with side XY. Side AB corresponds with side XY. Again, for my statement, I can say that side BC corresponds with which side? YZ.
We should give it a breathe.
Alright, so we have then that BC goes with YZ. What's my last statement? Go ahead and write down that last statement.
Okay.
Alright, so we said BC corresponds with YZ. And my last statement, AC, what does that correspond with? XC. Now we were able to pull these three ratios, these three statements of proportionality, from my statement given here. But if they did not tell me that, and you have a picture with numbers given to you, then make sure you match up small with small, medium with medium, big with big. So for example, if I look at my triangle on the left, what's the smallest side here? 50. And what's the smallest side on my right? 6. So we are comparing small with small, medium with medium, big with big. And if we look, this is indeed AB, and this is indeed XY. Okay, so if they don't give you that statement, just compare the sides in order of size. Okay, so let's go ahead and write these out, and then we'll simplify them. BC was 25, and YZ was 10. AC is 20, and XZ is 8. Do we agree with these? Guys, do we agree?
Yeah.
Making mistakes? Alright, so we are checking each of the comparison of the sides. Now what we need to see is, are they the same? What does 15 over 6 reduce down to?
5 over 2.
Do we agree with 5 over 2?
Yes.
Alright, 25 over 10, what does that reduce down to? Alright, looking good so far.
Oh my god.
Don't automatically assume, make sure you do double check it. What does 20 over 8 reduce down to? Okay. See how each of these are the same ratio? So that means then the corresponding sides are proportional. Corresponding sides are proportional, so we have these figures are indeed similar. Now they gave us that, we know that they're similar. But if we were checking, that's what we would have to do. Now it asked us, or didn't ask us, sorry. We can go ahead and identify our scale factor. So let's go and write our scale factor. So scale factor. And they gave us already the order here, if they do not give you the order, then you go ahead and specify. I'm going to go ahead and just rewrite it. My scale factor of triangle ABC to triangle XYZ. Let's put it in.
Was 2 with the similar sign, or just 2?
2 is fine because I'm just listing my scale factor. So again, scale factor is just the ratio of my sides. What was the ratio of each of my sides? 5 to 2. Now, again, you could write this as a colon, you could write it as a fraction, you could write 5 to 2. But that's going to be my ratio there. They did not give us units, so we do not have to give units. But again, notice ABC, that was my larger triangle. That's the larger value of my scale factor. XYZ was my smaller triangle. That's the smaller value of the scale factor. So let's go to Monty first. What was your question?
We have to prove triangles.
Yes. Exactly. So we are going to have to go through and prove triangles are similar if I still turn around. So in order to do that, we need to state that the corresponding angles are congruent. And we also need to check each of these ratios. Now, as you're checking your ratios, you must label. I do not want to just see 5 halves, 5 halves, 5 halves. I don't want to just see numbers. I need to know that you're comparing the proper sides and getting your ratios. Okay?
What if that didn't match up?
Then these figures would not be similar. Now here they gave us they're similar, so they have to match up. But in proving that they're similar, if they're not, then you would say figures are not similar.
So you have to say it like that every time? Just like that? Yeah,
so we want to state what sides we're comparing and what are the actual values. Now, if you're able to simplify in your head, that's fine. But I do need to see that those statements.
What if there's no units?
Then we don't have to do units.
Okay.
Yes, Teresa.
We don't have to do like the first bit like this, right?
We will be doing proofs. We do proofs
Like
every unit.
this.
With this type of stuff, yeah, by the time we get to proofs, we're going to have some of those shortcut ways. So we probably won't be doing all for this 6 pieces.
Proofs is everywhere?
Pardon, geometry? For this part here. This is just, we're just simply checking our ratios to see if they're the same. Now guys, I had us go through and do all 3 just to verify that it was the same. But if they told us it's similar, that means that they are going to be the same. So you can just compare one set of sides and that's your scale factor. So if they give us they're similar, the scale factor will be just the ratio of the sides. Alright, so for this next example here, we are asked, are they similar? And we have to show this. So this is us proving that these are similar. Now we're dealing with a quadrilateral, so I should have 4 sets of angles, 4 sets of sides. It does require quite a bit of work, but we can do it. So 4 sets of angles, 4 sets of sides. So are the polygons similar? If they are, write a similarity statement and give the scale factor. So can we see, do the angles match up?
Yes.
Alright, so we've got to go ahead and state that. So we have angle H is congruent to angle R. We have angle D is congruent to angle P. Angle E is congruent to angle L. And angle G is congruent to angle Q. Alright, so that takes care of our angles. We have shown that all 4 sets of angles are congruent. Now we do have to check each set of sides. They did not tell us that they're similar, so that's what we're checking. And here, this is where you want to match up small with small, medium with medium, big with big. Alright, but you must state what sides are you working. So what's my smallest value on the left?
12.
And what's my smallest value on the right? 8. So I am comparing EG with LQ. Okay, so the measure of EG was 12, the measure of LQ was 8, and what does that simplify down to?
3 over 2.
3 over 2. So we're hoping to see 3 halves for each of them, but we do need to check that. Alright, let's do our next side. So, would you agree 18 and 12?
Yeah, I agree.
There we go.
Wait.
Alright, again, make sure you specify what sides you're comparing. DE to PL. And notice that I'm staying consistent that the left shape is on top and the right shape is on the bottom. Make sure you stay consistent with that as you compare. Otherwise you'll confuse yourself, right? Alright, 18 over 12. What are those both reduced by? 6. So would you agree that goes us down to 3? Alright, now, interestingly for this last situation, they end up being the same measures. 24, 24, 16, 16. So what's nice is we can go and write that in one statement. So I'm comparing DH. What am I comparing DH with? PR. Good, PR. So I'm comparing DH with PR. And that's what, 24 to 16? What are those both reduced down to?
12 to 4.
12 to 8. So 3 to 2, right? They're both divisible by 8?
Yeah.
So 24 divided by 8 is 3, 16 divided by 8 is 2. Now, this was the exact same measurements as HG to RQ. Do you agree? Alright, so since they are the same, I'm going to go ahead and say, which is equal to, maybe. So that's the same thing as HG to RQ. Now we were only able to write that in one statement because they were the same values there. Yeah, that would be fine. You could write it on the other side. Alright, so we have checked that our angles are the same, and we have checked each of our 4 sides. Are each of the 4 sides the same ratio? Alright, so now we can go ahead and state that the triangles, are the polygons similar? Yes.
Wait, what's a polygon symbol?
We don't have one, you just have to write out the letters for it.
Oh, that's it.
Alright, so if they are, write a similarity statement. So, as Faisal was asking, we don't have a symbol for a polygon, we just have to write out the letters. Now, as we name these shapes, we go in either clockwise or counterclockwise motion. It's up to you. You just can't skip all around, you have to go in either clockwise or counterclockwise motion. I'm going to start off with D and go clockwise. So, D, E, G, H is similar to, and make sure you match up those letters, D corresponds with P, so P, L, Q, R. And you can use those angles to help you out. So polygon DEGH is similar to PLQR. That's my similarity statement. And then my scale factor. Good, my scale factor is 3 to 2. And again, since we specified already the order here, we don't have to re-specify because again, we are just keeping with that similarity statement.
So we made all of that, right?
Yes, you have to check all sets of corresponding sides. Because in order for them to be similar, all 4 sets of sides need to be proportional. Other questions with this one? We're good? Because I hear a lot of talking on the side. I'm really concerned that when you go to do your homework, we're going to be confused because we're talking. Are we good with it?
Yeah.
Alright. So now let's take a look at our last 2 pieces of information. So this is just an important tidbit that we're going to deal more with later on in the year, but it comes into play now, so we're going to go ahead and introduce it now. The ratio of the sides of 2 similar triangles is the same as the ratio of the perimeters. The ratio of the sides is the same as the ratio of the perimeters. So if I know then, for example, up here at these triangles that we did, if my ratio of my sides was 5 to 2, then the ratio of the perimeters will also be 5 to 2, which means I can set up a proportion. So, for example, let's say that for this one, so again, my ratio is 5 to 2. Let's say that the perimeter of triangle ABC, we don't know the numbers. Let's say I told you my perimeter of triangle ABC was 50. And the ratio again is 5 to 2. What would be the perimeter of the smaller triangle?
20.
20. Because the ratio is 5 to 2. So 50 to something needs to simplify down to 5 to 2. In other words, my ratio is 5 to 2. I know my perimeter is 50. I don't know my perimeter for that guy. You cross multiply and solve, you get.
Oh.
Okay? So this allows me to set up that proportion that helps me to solve it. And again, we'll deal with that more within our homework. And then our very last thing here says the angle similarity postulate. So this is your first way, your first shortcut to show that two triangles are congruent. So this is one of your postulates. And you can rewrite this. A little squiggle means similarity. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So just like we had the shortcuts before, if I had triangle ABC and XYZ, and I was given that A is congruent to X and B is congruent to Y, based upon just that information, I could go ahead and state that triangle ABC is similar to triangle XYZ by the angle similarity postulate. So again, this is our first of a few shortcuts to showing that two triangles are similar. Because then once I know they're similar, I can set up proportions with their sides and the ratios there to solve. Amani? You know, angle is actually taken care of by just angle. Because the third angle theorem says if these two are congruent, then that third one's congruent. So if I just have two, that immediately takes care of that third one. It's a good question.
What's the difference if I say they're similar or they're congruent?
Congruent means the exact same shape and size, so the sides have to be the same length. Similar, they're different sizes, but that same shape. So that's why we have the angles are congruent. The sides are different values, but they're the same stretch. Other questions with this? Alright, so your homework for tonight, please listen up. Your homework for tonight is worksheet 1 and worksheet 2. Yeah, ideally next class.
Sorry, that is white. White was in the recycling.
Well, there's no yeah, there's no sushi, right?
It was, but it was not what it was.
Oh, no, it was. I don't get it. What do you mean? Oh, this is bad.
You need the worksheet too?
That's unfair.
I need worksheet too. See, senor.
Where are you going?
No, it's not. Even better. Oh, yeah.
Nice. Alright guys, listen up. Your homework is both worksheet 1 and worksheet 2. If you get stuck, look at Blackboard. There's some helps there for you. You may go ahead to lunch.